Hello, welcome to the first video for section 8.3. We're talking more about operations on radicals. So here's where we get a little bigger. The first four operations, addition, subtraction, multiplication, division, within a radical, that's what we talked about in the first one. Notice how each radical, kind of its own, right? You had square root here, cubed root there. You never really had any combined expressions. But what happens when you have something like this, where you have subtraction and multiplication and addition all together? Basically, what happens is the same thing we did before. It follows PEMDAS, it follows FOIL, it follows our rules of polynomials. So let's revisit multiplication of polynomials for a second. When we multiply two binomials together, we have to think about distribution. In other words, everything needs to get paired up. Now again, there's 287 different ways to organize this. You can do FOIL, box, table, I don't care, whatever helps you see. But we need to match up this 5x to both those terms and this 3 to both those terms. So we end up with 1, 2, 3, 4 things, and then some stuff might end up simplifying. This does not change with radicals. We have to have the square root of 5 go to both those terms, and the 3 go to both those terms. And in doing so, we end up with 1, 2, 3, 4 pairs, okay? The only difference is we'll probably see, well, actually, I wouldn't say less simplifying. You could see more, you could see less. It will most likely not follow this goes down to 3 terms pattern, though. So let's take a look at this one again. We've got 7 minus the square root of 3 times root of 5 plus root of 2. Now, we just want to make sure we do our distribution idea. So we're going to have 7 times the first one and 7 times the second one. Now we're going to do the second here. We've got minus root 3, I'll use parentheses, root 5, and minus root 3 times root 2. Now, if it would help you to put addition signs in between everything, that's fine. But then recall, since it's a minus 3 anyways, they're going to end up being, oops, that was too much. They're going to end up being, oh my heck. They're going to end up being negative. Anyway, there we go. Sorry about that. My eraser is overzealous today. All right. That should have been a 2. Let's go ahead and simplify what we can. 7 root 5 doesn't really simplify all that much. And 7 root 2 doesn't really simplify as well. From the last video, we saw that we can change this to 15 and this to 6, but even then 15 and 6 would not combine. And so we end up with a 4-termed finished product. Let's head over here to B now. We've got some things that look strangely similar, root 10 plus root 3 and root 10 minus root 3, but the process is still the same. So we'll do root 10 times root 10, and then we need a square root of 10 times, negative square root of 3. The other set now, we have positive square root of 3 times positive root 10. And the last one here, we have positive root 3 times negative root 3. Now notice I did put parentheses around that second one when there was a negative there, because I wanted to remind myself I'm not subtracting them. I'm actually multiplying them out. Okay, going one step at a time, this changes to 100. That minus may be in front of that second one, but it is just acting as a -1 coefficient, which means I can sneak it out front and make this a positive 30. That one would be plus root 30. And this last one, again, this little negative could sneak out front, and I'd have square root of 9. A lot more can be simplified here. So this is where we stopped on the last one because there was nothing in common. But here, square root of 100, that's a whole 10. That's beautiful. Square root of 9, and that's a minus 3. And then here I see a negative root 30 and a positive root 30 that are going to cancel each other out. I'm left with 10 minus 3, aka a whole 7. So we can go as far to unsimplified as all 4 terms are individual, all the way to everything combines and we end up with a whole number. So there is no guarantee of what you're going to end up with at the end with the combining. The process, however, is exactly the same. Let's do a couple more, get some nice familiarity with this. Remember what happens when you have a square? Definitely not that. Do not do this. Do not do that. Do not distribute. Okay? No distributing of the square. Instead, and the reason is because of this minus. It's not because of the square. The minus is the thing that kills it. Addition and subtraction always mess it up. Instead, we'll interpret this as something times itself, because that's what square means. And so we'll go ahead and do the same process we did before. Root 7 times itself plus root 7 times a negative 3 minus 3 times a root 7 and minus 3 times minus 3. Okay, here we get root 49. Here, again, that minus can just go in front, as the whole 3 can go in front because it's a factor. Minus 3 root 7. And negative 3 times negative 3 is a whole positive 9. Little more to simplify here. Careful, those middle two are not going to cancel. In fact, they're going to add together to double. They're going to be negative 6 root 7. That's going to be a whole 7. We got plus 9. 7 and 9 can combine to 16. And we get 2 terms this time. So again, no guarantee of what you're going to get when you have radicals in there. All right, let's do another one. Looks oddly familiar to the first one, but this time it's got, the second one. This one has a cube in it. Luckily, nothing changes. So I've got 5 times 5. I've got plus 5 cubed root of 3. Oops. Negative cubed root of 3 times 5. And negative cubed root of 3 times cubed root of 3. Okay. So here I've got 25. 5 cubed root of 3 is about as basic as it can go. I can sneak the 5 in front just for clarity's sake here in the next one. This one I have to be careful. Remember, we're not dealing with a square anymore. I need 3 to be a whole number. And so, I need a pair of 3, a group of 3 to be a whole number. And so this is actually just going to be the cubed root of 9. When it comes to simplifying, it just looks like these two will cancel each other out. We get 5 minus the cubed root of 9. There we are, which is not 25 minus 3. It wouldn't be 25 minus the cube root of 9 as my final finished product. All right, let's try a couple more. I highly recommend you try these last two on your own. See if you've actually got this. If you do, great. I'll stop talking for 5 seconds so that you can pause video and try. Okay, so hopefully you pause the video. If you notice something, if you remember something about these being difference of squares and what they will multiply out to, good for you. If not, then you will get the same answer if you just continue with the route we were going. Root k, root k, root k, root y, negative root y, root k, negative root y, negative root y. When you have a lot of the same thing all over the place, be very careful about how fast you go. I get root k squared, so root ky minus, I'm going to go with alphabetical order here, ky minus root y squared. Now what happens when you have a square rooted? They cancel, so I get a whole k here. These two cancel each other out. I get a big nothing. And again, those cancel out. So we get k minus y as our final answer. All right, we're going to use this in just a second, so go ahead and put a star by it. We're going to bank off that idea there. All right, this last one, though, let's just keep going with this idea. I've got 2 root 3 times 3 root 3. Come back to that in a minute. Plus 2 root 3 times negative 2 root 5. Here we've got root 5 times 3 root 3. And positive root 5 times negative 2 root 5. Okay, I'm just listing out which two are multiplying. I haven't actually done anything yet. Now, if I go zoom in on this first guy here, I've got 2 coefficients that are going to multiply to 6 and root 3 squared. Over here, I've got 2 coefficients that are going to multiply to negative 4 and root 15. Here, I've got, I guess you could write this as 3 times 3 is 9. Either way you want to do it. We've got 1 coefficient here and root 15. And then a minus 2 coefficient, root 25. Can I simplify anything further? Yes, I can. This becomes 6 times 3. This last one on the end becomes negative 2 times 5. These guys don't change. See, now we've got an 18 here. Minus 4 plus 3, root 15s leave me with negative 1 root 15. Minus 10 from the 2 times 5. So final answer, negative 8 minus root 15. All right. That's where we're going to stop on this video. If you have any questions about any of those, reach out to your teacher. Otherwise, we'll talk about rationalizing in the next video. See you there.